Hello, happy Wednesday. We just got back from a great field trip with 30 of our students. They had a chance to go and learn about hydroponics, which was pretty cool. So, sorry I didn't get this up yesterday, but we're talking about Tuesday's work, which really is a challenge in Guess-Check-Generalize. So this is a new method that I introduced to students as a way to take a problem that you may not be able to solve right away. It's a word problem, it's a riddle, it's something where there's some unknown that you need to figure out, and how to generalize so that you can use the tools that you already know in order to solve. So this given problem said that we had 3 people, Jerry, Dino, and Specs, and they have a combined age of 273. Dino is a year older than Jerry, and Specs is a year older than Dino. How old is each person? This kind of question, well, we have 3 different things that we don't know. Let's start with a guess. So if I wanted to start with a guess, well, I need it to be a reasonable guess. So I know that Jerry, Dino, and Specs are going to have a combined age of 273, so I'm going to be adding things together. And I know that Dino is a year older than Jerry, and Specs is a year older than Dino. So we have kind of going up consecutively. So let me just take a guess for Jerry. Let's say Jerry's 80. Then that means Dino would have to be 81. And Specs would have to be 82. Notice that I did not stress about whether this was right. We had students who thought of what would be a reasonable guess, and they did 273 divided by 3 to get a general sense of where people would be. That's excellent. You don't even need to stress that much. You can just make a guess. Because now we're going to need to check that guess, and this check is where you're going to come up with the tools for generalizing. So if I now check, since they have a combined age, I need to be adding, and I want to see if it's going to add up to 273. So if I do 80 plus 81 plus 82, well, that's 240. Nope, that's 243. So is that equal to 273? No, it is not. But it gives me the tools for generalizing. Because I don't know Jerry's age. If I don't know his age, what could I put in? I could use any kind of variable, some unknown. So just to back up, when I say generalize, I mean you are making a general rule that is going to work for any numbers. So that usually is going to be moving into variables. We're talking about algebra now. So since I don't know Jerry's age, I'm going to start with Jerry, and let's just say Jerry's age is G. So I need to figure out from there, how could I express Dino and Specs' ages? Well, looking back at my check, and my guess, honestly, if Jerry was 80, Dino was 81. So I had to go up 1 more. And if Jerry was 80, Specs was 82, so I had to go up 2 more. So a way that I could express that would be that Dino is Jerry's age plus 1 year, and Specs is Jerry's age plus 2 years. Using my check section, I know that I need to be adding those 3 ages together and that they should be 273. So I could set myself up an equation. G plus 1 plus G plus 2 needs to equal 273. And then we can collect our terms. How many G's do we have? We have 3 G's. And then we have 1 plus 2 plus 3 is going to be 273. And from here you could solve. You could use a balance method, you could use algebraic method, or you could use a number trick. And when you solve this, you would find that actually G needs to be 90. So if G is 90, actually, Jerry's age is 90, Dino's actual age would have to be 91, and Specs' actual age would have to be 92. And I can check that if I do 90 plus 91 plus 92, that's going to give me a combined age of 273. So I wasn't right the first time. My guess was wrong. That was fine because I was able to use that to generalize. So let's look at one more and see if we can come up with a generalization here. We have 4 people with a combined age of 92. We've got Allie, who's the youngest. We've got Bob, who's 2 years older. So let's say plus 2. We've got Charlie is 2 years older, plus another 2. And we've got Darwin is even 2 years older, plus another 2. And we know we need a combined age of 92, so we're going to be adding them together. So again, let me just guess. Let's say Allie's age is 10. 10 plus 2, I know Bob would have to be 12, Charlie would be 14, and Darwin would be 16 years old. That's That's my that's my guess. Now to check, 10 plus 12 plus 14 plus 16, is that equal to 92? No, it's not. But I can use this. So to generalize, Allie, well, why don't we just start with Allie's age? Allie's A, but we don't know what that is. However, we know that if Allie is A, you have to go up 2 to get to Bob. You have to go up 4 to get to Charlie. And you'd have to go up 6 to get to Darwin. So if we wanted to write that as an equation, we would add those 4 ages together, and that needs to equal 92. We could collect terms, 1, 2, 3, 4 A's, plus 2 plus 4 plus 6 plus 12 needs to equal 92. Once again, you can solve it using your method of choice. And Allie's age would actually have to be 20. That tells us if Allie is 20, Bob has to be 22, Charlie has to be 24, Darwin has to be 26. So the reason that I want you to be using Guess-Check-Generalize is because I do not want you to be paralyzed when you start a problem. Don't look at it and say, oh, I don't know the answer. I don't already see what the answer would be, so I don't know where to go. Be okay with making a guess. However, then once you've made that guess, you should not keep going back and guessing. That's not efficient. So how can you use your check to then help you come up with a generalization? You might need to do a couple different guesses to help see how you can generalize, but you shouldn't be doing 5, 6, 7, 8, 9, 10 guesses until you get the right answer, because you can be more efficient and more strategic if you generalize. All right, have a good night.